All right, good afternoon again, everyone. So, welcome to the Thursday edition of our Math 155 discussions. As I've mentioned earlier, medyo um, meron pa rin akong hangover ng bakasyon noong Tuesday. So, nakalimutan ko yung routine sa klase. I forgot to press the record button for last Tuesday's lecture. So, what I shared instead for you guys para sa Math 155 Section X ay yung recording ng discussion ko sa Math as a Section V nung Tuesday. So, I apologize for that. Hopefully, hindi ko makalimutan mag-record again. Pero the nice thing is, meron akong existing recording at saka meron akong isa pang classes. So just in case talagang makalimutan ko, meron akong ma-share sa inyo. So in case I forget, pakisabihan na lang, paki-remind na lang ako ano. So but anyway, that's it. And another housekeeping matter, as promised, tomorrow I'll give you the next homework for Math 155. It will be due on Tuesday. So kindly mark that on your calendars para maplano nyo siya. Hindi nyo man siya gawin bukas. So meron kayong Tuesday, Monday and Tuesday next week to work on it. It will just be a short homework. Probably it won't eat up an hour of your time. So yeah, kindly take a look at that. So last Tuesday, we started looking at the third unit of the course. And we said here we will just be rebuilding the usual calculus that we know, the concept of the three pillars, limits, derivatives, and integrals. Now we are starting with limits of functions. And what we are doing is taking advantage of the things that we learned from units 1 and 2, right? Kasi medyo kakaiba yung approach natin from Math 36 kasi meron na tayong mga additional learnings ngayon about the set of real numbers as a complete ordered field and as well as limits of sequences. So we'll take advantage of these things para mas mapadali yung reconstruction natin ng teorya ng limits, derivatives, at integrals, right? And the concept of limits plays a very important and central role in calculus kasi yung derivatives, makikita natin later or nakita nyo sa elementary calculus nyo, ito ay limit lamang ng mga difference quotients. So, ibig sabihin, it's just a limit of some quantity. Also, integrals are limits of Riemann sums. So, talagang dun sa natitirang dalawang big branches or big concepts in calculus, nagpe-play pa rin ng central role yung limits. So to have a wider view of calculus, kasi advanced calculus na nga tayo, meron kasing mga detalye at mga iba't ibang consequences na hindi natin na-explore totally sa elementary calculus, sa Math 36, 37, and 38, because in order to do so, kailangan natin yung mga mas malalim na konsepto, katulad nung sa konsepto natin ng limit ng isang function. Dati, ang preamble natin o na-define lang natin yung yung limit ng isang function for those functions who are defined in some open interval containing the number c of interest. All right? So limitado tayo doon. So with that in mind, we were not able to define what the limit of, say, square root of x as x approaches 0 is. Kasi hindi siya sakop ng definition ng Math 36 because, again, kailangan natin ng open interval containing 0 kung saan defined yung square root of x sa lahat ng mga numbers dun sa loob ng interval na yon. So because any open interval containing 0 will contain negative numbers for which the square root function is undefined, hindi natin kayang i-define ito sa Math 36. Medyo nagpalusot lang tayo ng konti para masabi na the limit doesn't exist na nag-discuss na tayo ng left-hand at saka right-hand limit sa Math 36. We said that the limit will exist if and only if the left-hand and the right-hand limit will agree with each other. No problem in taking the limit coming from the right ni 0. Ang limit niya ay 0. Pero coming from the left, wala tayong masabi kasi walang function mula dun sa kaliwa. So using the framework developed for Math 36, we said na the limit of square root of x as x approaches 0 doesn't exist. All right? But at this point, we are mature enough. Mas marami na tayong alam, so we can take a look at the concept of limits from a wider perspective. And for instance, in our definition, we're using the concept of a limit point. Hindi natin kailangan magkaroon ng isang open interval containing the number c, for in this case the number 0, kung saan defined all throughout yung function. Kailangan lamang nating magkaroon ng limit point. At dahil dahil si 0 ay isang limit point ng domain ni square root of x, which is the set of all positive real, non-negative real numbers, si 0 ay accumulation point netong set na to. Kasi kahit anong maliit na epsilon neighborhood ni 0, lagi nagko-contain ng mga elements ng domain. Yun nga lang, nasa kanan ni 0 yung mga elements ng domain na nagkukumpul-kumpulan around him. Alright, or around 0. Sa Math36, hindi pwede yon kasi sabi natin dapat titingin ka sa kaliwa, titingin ka sa kanan ni 0, tapos dapat dun sa mga numbers na yon defined yung function, tapos meron silang same behavior. Sa Math 155, walang ganon. Kailangan lamang meron kang limit point. So in this particular case, there's only one way to approach a 0, and that is through elements of the domain coming from its right. So, but that will not stop us from defining what the limit of this function is. Hindi to sakop nung unang definition, nung epsilon delta definition nyo sa Math 36. Sa Math 155, sakop siya ng definition 3.1. So we can definitely talk about the limit of this function. And actually, I think last time we concluded that this is equal to 0. Kasi kompleto na yung theory natin ngayon. So we can rightfully say the limit of square root of x as x approaches 0 is equal to 0. And if you're not convinced, sige, papakita ko yung proof kung bakit sure tayo ng ang limit ni square root of x as x approaches 0 ay equal kay 0. All right? But probably we can do a preliminary analysis first. But of course, we will note dun sa formal proof natin, sisimulan natin to by saying that 0 is a limit point of the domain of the function, just for us to be sure na covered siya ng definition 3.1. Okay? Tapos remember sa preliminary analysis, we will consider an arbitrary epsilon greater than 0. Okay? And we wish to find pangit palang WTF yung gamitin ko sa we wish to find, ano? So we want to find a delta greater than 0 such that the absolute value of root x, such that x being within delta units away from 0 guarantees na yung f of x minus the purported limit ay magiging less than epsilon din. So ito yung condition na gusto nating ma-achieve. Binigyan tayo ng isang arbitrary epsilon greater than 0, kailangan nating makahanap ng delta. Para saan si delta? Si delta dapat yung isang real number that can guarantee this implication. That if I get the number x within the delta neighborhood of 0, then dapat yung function value minus L will be less than epsilon. Okay? Tapos alam nyo na yung mangyayari. So I will be working backwards. So I will investigate how square root of x minus 0 behaves, and then try to deduce a restriction on delta. Okay? Ano yung condition na kailangan ma-achieve o pwedeng ma-achieve ni delta para mag-guarantee na mag-hold yung epsilon inequality. So paglalaroan ko lang to, absolute value ng f of x minus L, alright? Then this will just be square root of x, okay? Dahil positive naman lagi ang principal square root ng kahit anong non-negative real number or isang positive real number. So that's it. And what can we say about this? Well, we know from what we will assume later na pwede nating gamitin ang absolute value of x ay less than delta. Right? Pero si absolute value of x ay, si x ay sure tayo ay positive. Kasi nga ang domain ni square root of x ay 0 to positive infinity lamang. So we are sure that x is greater than 0, okay? But less than delta. So by property of the square root function, pwede kong kunin yung square root ng both sides. So si square root of x will then be less than square root of delta. All right? So remember, pag nagtitake tayo ng square root ng dalawang sides ng isang inequality, tapos alam natin na parehong sides ay non-negative, then hindi nababago yung inequality when we take the absolute value. So this is the restriction that we have, all right? So, galing dun sa i-assume natin later dun sa proof, nakuha natin ang square root of x ay less than delta. So, meaning, ito ay magiging less than square root of delta, all right? Pero ang gusto ko talaga mapakita ultimately is this guy. So, kailangan ito ay mabound above by epsilon. So, what I'll do to guarantee that is I will restrict my choice of delta so that square root of delta will be less than or equal to epsilon para mag-guarantee itong epsilon inequality na ito. All right? And this will give us our choice of delta. All right? So what will be our choice for delta? We will choose deltas, or we can choose any delta such that it is less than or equal to any given epsilon squared. Okay? And this is fine because parehong positive yung dalawang sides ng inequality. Pag in-square mo ang sides ng parehas na sides ng isang inequality na alam mo ay parehas positive, hindi nagbabago yung inequality symbol. All right? But you can only do this kapag ka positive itong left at saka right side. Pagka kasi hindi, kailangan mo i-consider yung case na baka mas malaki yung base ng negative than the base of the positive. So meron mga little details, but the nice thing is all of them are positive. So squaring and taking the square root of both sides of an inequality can be naturally done. Okay, so that's it. We were issued a challenge epsilon. We have learned that we can choose delta to be anything less than or equal to the square of that given epsilon. And this is what we will write in our formal proof. So in our formal proof, we'll start by saying that note that 0, the given value for C, is an accumulation point of the domain of the square root function, right? So this is the domain of square root of x. So dahil accumulation point siya, it makes sense to talk about the limit of square root of x as x approaches 0. Ito yung kulang sa math 36, alright? Kasi dito pa lang babagsak na yung square root of x at x equals 0 kasi walang open interval na nagko-contain kay 0 kung saan define yung function all throughout. Okay? But now we can do this, alright? Then given any epsilon greater than 0, we can take delta to be equal to epsilon squared. Okay? Then, moreover, we can say that if x minus 0 is between, or has absolute value between 0 and delta, then we can have the following. Ang square root ni, ang absolute value ni x, which will be equal to x, will be less than delta. All right? So, sorry, tama ba? Yeah. Alam natin to ay less than epsilon squared. Also, we can take a look at absolute value of f of x minus the purported limit. All right? Then I will manipulate it. Gusto kasi mapakita ito ay less than epsilon. Okay? But an easy way to do that is what? Okay, this will just be square root of x. And we know that square root of, we know that what? Kailangan ko pala yung isingit dito. So dahil si x ay less than epsilon squared, si epsilon squared ay positive, si x ay positive, then I know that this will imply that square root of x is less than epsilon. Okay? So thus, hindi na pala to also, pwede nang thus, we have the epsilon inequality. Right? And that ends the proof. Therefore, the limit of square root of x as x approaches 0 is indeed equal to 0 insofar as math 155 is concerned. So sa advanced calculus, this will hold. All right? Kasi medyo kakaiba, mas generic yung definition natin ng limit ng isang function. All right? So ito yung mga subtle differences. And we will see some of these later, lalo na dun sa mga cases na hindi covered ng Math 36 definition ng limit. Okay. Now, I think that concludes section 1. Nasa section 2 na tayo. So section 2, titingnan natin ano yung relationship between limits of functions at saka limits of sequences. Remember that it is my promise that we can take advantage of the theorems that we have developed for limits of sequences para ma-prove yung mga statements regarding limits of functions. And primal to do so is Theorem 3.1 because this spells out ano yung equivalence ng pagiging limit ni L ng isang function, okay, at si L pagiging limit ng isang sequence ng mga function values. Okay? Now let's see. Now, Theorem 3.1 will hold only for functions f defined on a set A who has x sub 0 as one of its limit points. So ganun pa rin. Assume natin si x sub 0, which is our point of interest, is a limit point of the domain of the function f. Then Theorem 3.1 claims that these two statements are equivalent, meaning there is a biconditional relationship between statement 1 and statement 2. Statement 1 is pretty simpler than statement number 2 because it tells us just that limit of f of x as x approaches x sub 0 ay equal kay L. So ito yung limit ng f taken as a function with domain capital A. All right, so nothing too fancy about that. Pero medyo mas komplikado, hindi pala medyo, mas komplikado talaga yung statement number 2. So sabi ng statement number 2, for any sequence x sub n belonging to or properly contained in the set A less set containing x sub 0. So itong phrase na to, ibig sabihin daw, kahit anong sequence na mga terms ay nanggagaling kay A pero hindi nagiging equal kay x sub 0. So this will just be a sequence of elements of the domain except the limit point of interest x sub 0. Okay. So sabi nito, kukuha tayo ng kahit anong sequence. Ano yung property ng sequence na yun aside from not having x sub 0 as one of its terms? Dapat siya ay nagko-converge kay x sub 0. So kumuha ka daw ng kahit anong sequence galing dun sa domain na nagko-converge kay x sub 0, magfa-follow daw na yung limit ng f of xn as n approaches infinity ay equal kay L. All right. What I want you guys to take note of in this particular point of our discussion ay yung difference between these two statements. Right? The first statement is kinukunan mo ng limit si f considered as a function whose domain is A. Kakaiba yan dun sa limit na nandun sa statement number 2 because yung nasa statement number 2 ay limit ng sequence. Look at this. You're taking the limit as n approaches infinity. Right? So that's a cue na, okay, yung limit na yan ay limit ng sequence. Tapos ito, limit ng isang function. Alright? So kaya ito yung defining theorem para sa relationship between limits of functions and limit of sequences. Now, let's take a look closer here. Okay. So, ang sabi rito ay ano yung itsura ng limit na kinukunan natin ng sequence dito sa statement number 2? Well, kukuha ka daw ng sequence na nanggagaling dun sa domain. Okay. So, kukuha ka ng maraming terms dun sa domain. Tapos, nag-approach daw yan ng x sub 0. Alright? So, whenever I say sequence na nanggagaling kay A, insofar as this discussion is concerned, please take note na may kaakibat yun na restriction na walang x sub n ang equal kay x sub 0. Alright? So, I hope that would be clear kahit na hindi ko siya mabanggit later pagka sinasabi ko kumukuha ako ng sequence galing dun sa domain. Ang understanding natin ay hindi si x sub 0 pwedeng maging term ng sequence na yun. Okay? So kukuha ko ng sequence, nagko-converge kay x sub 0 dapat. Tapos kukunin ko yung function value ng bawat isang term at i-consider ko yon as another sequence. Okay? So meron akong dalawang sequences ngayon. Sequence ng mga x, sequence ng mga function values. And this statement here is telling us that the limit of the sequence of function values is equal to L. Or in other words, the sequence of the function values of the terms in our sequence of xn's will converge to the number L. Okay. So, and then, ang claim ng theorem, equivalent yung dalawang statement na yan. Ibig sabihin, yung limit ni f taken as a function as x approaches x sub 0 will be equal to L if and only if I get any sequence, and again, any sequence from the domain of the function f na nagko-converge kay x sub 0 when I form another sequence, in particular, the sequence of function values of that sequence, then yung sequence ng mga function values na yon ay magko-converge din kay L. So you see that you can take you can look at the functional limit in terms of the limit of a sequence. All right? So kaya siyang tawag, ito yung sequential criterion para sa limit ng isang function. But I think this is nothing new. Medyo fancy lang yung pagkakabanggit sa Theorem 3.1. But I know that you have used at least one direction of this biconditional statement. Remember, tandaan niyo ba yung Hitching Theorem or yung Hitch Theorem mula sa Math 38? Does anyone remember? Or kinalimutan niyo na rin yung 38? Tama ba? Katatapos niyo lang ng 38, ano? Or you took your time before taking 155. So the Hitch Theorem, what does the Hitch Theorem tells us? Well, ito usually ginagamit natin pag evaluate ng mga limit ng sequences. Kasi sa Math 36, marami tayong natutunan paano mag-compute ng limit ng mga functions. Meron kang L'Hopital's rule, marami kang algebraic theorems na pwedeng gawin, and so on. Alright? Tapos pagdating natin sa 38, magpapa-evaluate tayo ng limit ng sequences. Kaya lang hindi lahat ng natutunan natin sa 36 ay pwedeng magamit sa mga sequences. Kasi halimbawa, yung L'Hopital's rule, kailangan differentiable yung function na kinukunan mo ng limit. Alright? Para magamit mo yung L'Hopital's rule. Pero yung mga sequences, wala yung konsepto ng derivatives kasi ang domain niya ay consisting of isolated points. Alright? So hindi ka pwedeng L'Hopital's rule kapag ka nagko-compute ka ng limit ng sequences. Medyo kakaiba to, Charles, sa squeeze theorem, pero pwede mong tingnan pa rin na squeeze theorem ito, pero dun sa squeeze theorem natin sa 155, medyo kakaiba tong Hitch theorem. Alright? So yung Hitch theorem, hindi ko alam kung Hitch theorem din yung tawag, nakikisakay yung limit ng sequence dun sa limit ng function. So I hope this will ring some bells. Halimbawa, given ako ng sequence, so pag ginraph ko yung sequence, eto lang, remember, it will be defined only for natural numbers, so it will just be a discrete set of points, right? So halimbawa, yan yung graph ng sequence. Tapos, syempre, halimbawa, komplikado yung definition ng sequence, mahirap siyang kunin ng limit. Tapos sabi natin, hold on, bakit hindi ko pwedeng gamitin or bakit hindi ko gamitin yung mga natutunan ko na tools sa Math 36? I will use the Hitch Theorem which tells me na yung limit ng sequence ay magiging equal dun sa limit ng function that is generated by extending the domain of the sequence. Alright? So ang gagawin ko lang, pwede ko pala itong i-join. Okay? Connect the dots tayo dyan. Okay? Tapos, magkakaroon ako ng continuous version nung sequence. Alright? Tapos, pwede na ako, dahil continuous to, pwede akong gumamit ng L'Hopital's rule kung differentiable yung function. Pwede akong gumamit ng iba't ibang mga techniques na natutunan natin sa 36. Kaya siya hitch. Kasi parang naki-hitch yung sequence dun sa behavior nung nung function na ang domain ay isang interval para mahanapan siya ng limit. So ito yung sinasabi na kung ano yung limit nung function, siya na rin yung limit nung sequence. So parang pwede natin yung tingnan as property or statement 1 implying property 2, right? Kasi ang ginawa natin sa 38, in-evaluate natin yung limit nung smooth function f, tapos kinongclude natin na yung limit na yon, yun na rin yung limit nung sequence na naki-ride doon sa graph ng function f. So that's 1 implying 2. Ang di natin pa nagagamit nun ay yung 2 implying 1, which is medyo kabaliktaran. Kasi mas magre-rely ako, sorry, may nalaglag, pero mas magre-rely ako ngayon dun sa konsepto ng limit ng sequences kasi mas marami na tayong alam about limit of sequences than limits of functions. So I can take advantage of the array of results that we have for limit of sequences to say something about the limit of a function. All right? But before we can do that, let's try to write the proof for theorem 3.1. Though given na yung proof dyan, let's try to do it freestyle dito para mas ma-explain ko rin yung parts ng proof even more in details. Okay? Now, as we have mentioned, theorem 3.1 is a characterization theorem. Characterization theorem siya, so it's if and only if. May dalawang parts yung theorem. The direct implication and the converse. So simulan natin yung proof dun sa forward implication, 1 implying 2. All right? So in order to prove 1 implying 2, so we will assume that the limit of f of x as x approaches x sub 0 ay equal kay L. Yan yung statement number 1. And from here, we want to show that any sequence x sub n, all right, na properly contained kay domain minus the limit point x sub 0 that converges to x sub 0 has the following property. Yung sequence ng mga function values nila ay magko-converge din kay L. Yan yung gusto nating ipakita, right? Na kapag kumuha ako ng kahit anong sequence mula dun sa domain na magko-converge kay x sub 0, yung sequence na mabubuo by the function values of the terms of the sequence will also converge to L. So that's our goal. And paano tayo makakarating sa goal na yon? Ito lamang yung pwede nating magamit so far. Okay? Yung assumption statement number 1. Okay. Now, how will we do that? Well, kakonti pa lang yung alam natin about limits, so which is lucky for us kasi kakonti yung options. So at this point, ang alam ko lang definition nung limit, nung L being the limit. So I'll write it down. So if we are given any epsilon greater than 0, then we can find a delta greater than 0 such that x minus x sub 0 being or having magnitude less than delta will imply absolute value of f of x minus L is less than epsilon. Yan yung definition ng limit ng function f. Okay. Now let's take note of this. The number delta is the distance associated with differences or with the distance yung delta, ito ay associated with the distance between x values. Meanwhile, epsilon is a number associated with the distance between the function value and the purported limit. Okay, so yan yung distinction natin kay epsilon at saka kay delta. Kasi medyo gagamitin ko yon. Kailangan ko kasing gamitin yung isa sa kanila para dito sa assumption na to. Alright? Kasi additional assumption siya. So, ang gusto kong, pag inassume ko to, gusto kong mapakita na yung sequence ng function values ay magko-converge kay L. Right? So, essentially, yun yung goal natin dito. So, what I'll do is to consider a sequence xn coming from this set that converges to x sub 0. And our goal is to show that the sequence of function values of terms of this sequence will converge to L as well. Okay? So yun yung goal ko. So ano pwede kong masabi ngayon? Well, the only information I get from here is that the xn's are all in the domain of A. And aside from that, that sequence will converge to x sub 0. So gagamitin ko ngayon yung definition ng convergence ng mga xn's papunta kay x sub 0. So that means for the same delta as above, all right? And siguro ito yung medyo kakaiba rito kasi yung definition natin ng convergence ng sequence, remember, for all epsilon greater than 0, there should exist a starting index capital N. So arbitrary epsilon will give us a starting index capital N. Yun yung nasa definition ng sequence. Pero, yung binuo ko ditong sequence ay sequence ng mga x values na ipla-plug in ko later doon sa function f. And remember, I noted earlier that the distance associated with x's ay si delta, which is supposedly to be any positive real number. Okay? So, parang papalitan ko lang yung symbol na ginamit ko dun sa definition ng convergent sequence. Instead of an epsilon, arbitrary epsilon greater than 0, I can use an arbitrary delta. Okay? Or you can think of it this way. So dahil convergent naman yung xn papunta kay x sub 0, ibig sabihin nun, kahit anong epsilon yung piliin ko, take note, kahit sinong epsilon. So kahit ang piliin kong epsilon ay the same delta as what we have in the definition of the limit of the function f, mag-hold, makakakita pa rin ako ng starting index capital N, such that whenever little n is greater than or equal to capital N, yung absolute value ng x sub n minus x sub 0 will be less than the delta. All right? So we'll have that. There exists a starting index capital N such that for all little n greater than or equal to capital N, yung absolute value ng x sub 0 or x sub n minus x sub 0 will be less than delta. Right? Is that good? Sir, bakit gusto mo less than delta? Sa lahat ng posibleng piliin mo ng epsilon, bakit yung delta the same as the delta that I have in the functional limit definition? Well, because of its implication. I know that whenever I get an x that is within delta units away from x sub 0, it will automatically follow that if I plug in that x into f, yung distance ng function value from L ay magiging mas maliit kay epsilon. Okay? So that means, si xn, si x sub little n ay within delta units away from x sub 0. So that means, pag pinasok ko si xn sa loob ni f, which is fine because x sub n belongs to the domain of f, so that's perfectly valid. Kinuha ko yung difference mula kay L. So ito yon, function value nung x na within delta units away from x sub 0 minus L ay magiging less than epsilon. Right? And then we'll review what we have so far. What we have so far is that if we are given an arbitrary epsilon greater than 0, we can always find a starting index capital N after which yung f of xn minus L ay less than epsilon. And that should remind you ng definition ng limit ng sequence. So this will imply that indeed the f of xn's will converge to L as desired. Okay? So does the proof make sense, guys? Okay, thank you. Doon naman tayo sa pakabila. Kalahati pa lang yon kasi biconditional nga yung statement natin, ano? So let's prove the converse. Dito naman, ang i-assume natin ay for any sequence of elements of the domain except the limit point that converges to x sub 0, we have that the sequence of f of xn's will also converge to L. So ang assumption natin dito ay kapag kumuha tayo ng kahit anong sequence na nanggagaling dun sa domain minus the limit point na nagko-converge kay x sub 0, automatic na magpa-follow na yung sequence of function values ay magko-converge kay L. Ito yung governing assumption dito. And what we want to show is that the limit of f of x as x approaches x sub 0 ay equal kay L. So yan yung goal natin. Right? Now, in order to do so, I will write a proof by contradiction. So let me note that here. This is by contradiction. Okay. Let me add a page. Okay. Now, so gagamit ako ng contradiction. So ano yung supposition ko rito? I will suppose, for the sake of deriving a contradiction, that the limit of f of x as x approaches x sub 0 is not equal to L. And I will show that there will be something wrong kapag ka i-accept natin as a fact itong supposition na ito. Okay? So sinasabi nito, ang limit ni f as x approaches x sub 0 ay hindi equal kay L. So kailangan i-negate natin yung definition ng limit. Alright? And that is the usual exercise sa Math 101. Ginawa nyo ba yan sa Math 101 nyo? Or kinalimutan nyo na si Math 101? Alright? So isa to sa mga classic na exercise sa 101. I-negate yung definition ng limit kasi may mga quantifiers involved doon. And again, hashtag, sabi ni Charles, war flashbacks once more. All right? At marami-rami pa yan. So flashbacks mula sa 101, 15, 36, 37, and 38. Okay. So in-negate ko siya. Ano yung definition? For all epsilon. Negation ng for all, there exists. So I can say here, so there exists an epsilon greater than 0. Okay. And then sabi sa definition, there exists a delta. So negation on there exists for all. So there exists an epsilon greater than 0 such that for all delta greater than 0, tapos in-negate natin yung implication. Remember, dun sa definition, meron tayong absolute value ng x minus x sub 0 less than delta, implying f of x minus L less than epsilon. All right? Ito yung in-negate natin. All right? So, ito ay conditional. Ang conditional statement ay nagiging false lamang kapag ka meron kang true statement implying a false statement. Saka lang magiging false yung implication. So true yung nasa definition, gusto natin siyang gawing false via negation. The only way to negate a true conditional statement is by making the consequent false. Right? So basically, mag-carry over pa pala to. Okay? Mag-carry over yung antecedent nung conditional statement, tapos in-negate ko lamang yung conclusion. So ito, instead ng less than, magiging false daw yung less than, so dapat greater than or equal to. Alright? So, dahil si L ay hindi yung limit ni f as x approaches x sub 0, then we are sure that there exists a positive number epsilon such that sa kahit ano pang delta na piliin mo, yung absolute value ng x minus x sub 0 less than delta is sufficient to imply that this guy is true. Okay? So yan yung sinasabi so far. Yan yung meron tayo. Now, I want to get a contradiction. And what I want to contradict is, actually, wala akong choice kundi i-contradict yung assumption. Ang assumption, kumuha ka ng kahit anong sequence na nagko-converge kay x sub 0, yung sequence of function values dapat mag-converge kay L. Right? Tapos dito sinabi natin na yung limit ay hindi equal kay L. So probably I can draw a contradiction from there. Okay? Now, una, kailangan kong bumuo ng sequence. Sabi dun sa assumption, kahit ano pang sequence yan. So free tayo to create any sequence that will be convenient for our purpose. Okay? Now, ano yung pipiliin ko na sequence? Well, okay. Well, I can consider, since x sub 0 is a limit point of the set A, then for any natural number n, okay, we have the following. Explain ko mamaya kung bakit. There exists an xn, element nito, okay. Now, ano yung sinasabi nito? Sinasabi nito na si x sub 0 Dahil si x sub 0 ay limit point by assumption ng Theorem 3.1, sa kahit anong natural number, okay, actually, hindi lang natural number, pero ibig sabihin, sa kahit anong epsilon neighborhood ni x sub 0 ay magko-contain ng mga elements ni A aside from x sub 0. Kulang pala to, no? Dapat ito ay may intersection A minus the set x sub 0. Yun. Yun. So kahit anong epsilon neighborhood around x sub 0 will contain members of A aside from x sub 0 itself. Definition ng pagiging limit point. So, ibig sabihin, kapag kinonsider ko yung epsilon to be mga 1 over n, kahit ano pa si n, sa lahat ng n, yung 1 over n neighborhood ni x sub 0 ay magko-contain ng mga elements ng domain aside from x sub 0. Tawagin ko silang mga xn's. Alright? Tapos, clearly, yung sequence ng mga xn's will converge to x sub 0. Alright? Kasi ganun ko siya pinili. Si x1 ay within 1 unit away from x sub 0. Si x2 is 1/2 unit away from x sub 0. Si x3, 1/3 unit away from x sub 0. Si x sub 1000 is 1 over 1000 unit away from x sub 0. And as n increases, yung mga xn palapit ng palapit kay x sub 0. So that's why it's clear to see na yung sequence ng mga xn ay nagko-converge kay x sub 0. And then, dahil nakakuha tayo ng isang sequence mula dun sa domain na nagko-converge papunta kay x sub 0, that means by our assumption in this part of the proof, it follows that the sequence of function values also converge and it converges to L. Okay? Now, yun yung sinasabi niya. Magko-converge yan kay L. So that means, ano yung masasabi ko ngayon kung nagko-converge yan papunta kay L? So kung nagko-converge yan papunta kay L, then what? Then for all epsilon greater than 0, there exists a starting index capital N such that after that starting index, yung absolute value ng f of xn minus L ay magiging less than kay epsilon na. Alright? Sabi nito ay kahit ano pa yung epsilon na piliin mo, laging may starting index na totoo tong epsilon inequality. But this is a contradiction. Contradiction where? Contradiction siya dito. Kasi ang sabi nung statement na to, alright? Merong isang epsilon, merong at least isang epsilon na kapag ka ito ay totoo, etong function value ni f of x minus L ay may absolute value na mas malaki or equal kay epsilon. Pero in this particular case, right? So we have found an xn that is sufficiently close to x, all right? Such that yung function value minus the limit ay less than kay epsilon. Ang ina-expect natin dapat greater than or equal yan kay epsilon by our supposition earlier. So there are two irreconcilable statements along this proof. So hindi tayo pumapayag na magkaroon ng internal contradiction sa ating system. So we are forced to conclude that our supposition earlier is false, meaning that the limit of f of x as x approaches x sub 0 is equal to L. And that ends the proof of our biconditional statement. Okay? So sige, absorb muna natin. Let's have siguro a quick break, 2 minutes. Kailangan ko na rin kunin yung charger ko na lalobat na si laptop. Hold on guys, so 2-minute break. Medyo kakaiba na naman pala, kakaiba na naman ang panahon dito sa amin. Kanina ay super init. Actually ngayon mainit pa rin. Pero pumapatak na yung ulan. I don't know kung naririnig sa audio ko yung thunders. So kanina ang lakas nung mga kulog. Kumusta naman sa inyo mga lugar dyan? Sobrang init. Yeah, tapos yun pa yung nakakaano, kapag uulan ng saglit kahit malakas yung ulan, pero kung abrupt yung pagtigil niya, no? Pagka after a few minutes, mas grabe yung init. Ano bang tawag natin sa sa init sa Pilipinas? Ito ba yung tinatawag na humid na summer? Yeah. Ito yung hindi ko na miss kasi uh, 5 years akong wala sa Pilipinas. Hindi naman full 5 years kasi every sem break umuwi ako. Tapos iniiwasan ko talagang umuwi ng panahon ng April, May. Though April, May hindi pa tapos yung second sem namin doon. So, pero iniwasan ko umuwi ng May at saka June. Kasi yun yung alam ko summer sa Pilipinas. So, yun yung isang bagay na hindi ko na-miss. Uwi na ako dito mga July na or early August para magbakasyon. Tapos ano na yun, medyo maulan na, no? So, yun naman yung kainitan sa Texas. So, iniiwasan ko talaga yung mga summer dun sa mga lugar-lugar. Pero parang mas matindi nga pala ang summer sa Pilipinas, ano, kaysa dun sa summer sa Texas. Kasi yun nga, medyo mas humid yung summers natin dito. Okay, so I think, sige, we're set to continue. Any questions so far? Okay, ready na ulit? Okay, so hopefully na-digest, na-absorb nyo na yung proof ng theorem. But what we'll do is to take advantage of the actual statement. At makikita natin paano papadalain ng Theorem 3.1 yung buhay natin pag-prove ng mga theorems regarding limits. And actually, Theorem 3.1, spoiler alert, will also give us a nice way or an easy way on how to show that the limit of a function as x approaches one of the accumulation points of the domain doesn't exist. Kasi dati mahirap yon sa Math 36 kasi kailangan nating bumalik sa epsilon delta, gamitin yung negation definition para mapakita na yung limit ay hindi equal sa isang number na ayaw nating maging equal dun sa limit. Okay? So we'll have an example about that later, and I'm thinking about giving that or giving such a question format to be your homework for next week. So kindly pay extra attention to that example later. Pero tingnan muna natin yung mga consequences ng Theorem 3.1. And you will recognize these results to be the theorems na kinonsider sa Math 36. Pero rito na downgrade sila. Ang tawag ko na lang sa kanila ay mga corollaries kasi direct descendants sila ng Theorem 3.1 and some results from Unit 2. Makikita natin kung bakit. Let's start with Corollary 3.1. Corollary 3.1 tells us na kung nag-exist ang limit ng isang function as x approaches one of the domain's limit points, then that limit is unique. Hindi mo pwedeng masabi na yung limit ni f ay equal kay L at equal din sa isa pang ibang number. Kung matatandaan nyo, na-prove nyo siguro to sa Math 36, proof by contradiction din, pero dumaan kayo sa epsilon delta. You considered an epsilon greater than 0, then you got a delta 1 for the first limit, say L, tapos delta 2 para sa isa pang limit, capital M. Tapos using some arguments, you were able to show that L is necessarily equal to M to avoid a contradiction. Okay? So pero epsilon delta yung ginamit doon. Dito sa proof na to, gagamitin ko yung konsepto ng Theorem 3.1. Ibig sabihin, yung statement about functional limits, i-convert ko into a statement involving limits of sequences. Tapos gagamitin ko yung corresponding theorem doon sa mula sa sequences via the converse of Theorem 3.1 para ma-deduce yung result para sa functional limits. So ganito yung mangyari. Suppose that f has two different limits, si L1 at saka si L2. Alright, meron siyang dalawang limit. So kung meron siyang dalawang limit, so una, yung limit ni f of x ay equal kay L1. So ibig sabihin, kahit na ano pang sequence ang kunin ko, alright, by Theorem 3.1, pag kumuha ko ng kahit anong sequence sa domain na nagko-converge kay x sub 0, yung sequence ng mga function values, sure ako magko-converge kay L1. Kasi si L1 is presumed to be a limit of f. So totoo ito. Alright? So everything is fine so far. Kaya lang sinabi natin may isa pang limit, si L2. So kung ang limit ni f ay equal kay L2, then sa kahit anong sequence xn na nanggagaling dun sa domain ni f, including the same sequence that we considered earlier for L1, yung same sequence na yon dapat mag-converge din kay L2. Alright? So nakita niyo yung translation, limit ng sequence, limit ng function, then using Theorem 3.1, kinonvert ko siya sa sequence. Tapos ngayon, doon ako mag-iisip ng mga results regarding limit ng sequences. I'll say, hold on, may problema yan. f of xn nagko-converge kay L1 and the same sequence, f of xn converging to L2, that is absurd, right? Hindi siya pwedeng maging totoo. Kasi alam natin, may theorem tayo mula sa limit ng sequences na ang limit ng isang sequence, if it exists, is unique. So that means L1 must be no different than L2. Right? So, dahil yon, contradiction na yon, so we can say na, okay, ganun din pala sa limit ng isang function. Pag nag-exist yung limit ng isang function, nag-iisang number lamang iyon. And you see, it's almost a 1 or 2 sentence proof. We don't even need it to consider an epsilon and consider a delta 1 and a delta 2, making our lives much easier. Okay? Much easier siya kasi nagawa na natin yung trabaho nung nag-prove tayo ng theorems about sequences. So para hindi lang ma-repeat yung process, we take advantage ng Theorem 3.1 at ng mga previous theorems. Okay? Ganun din yung nagiging kaso or magiging kaso para sa algebraic limit theorems. Ngayon naman para sa mga functions. Now, please make the following correction. Yung pangalo dapat limit ni g as x approaches x sub 0 ay equal kay m. Alright? Hindi ko pala ito na-correct last time. Alright. Now, ang assumption mo, may limit si f, may limit si g as x approaches x sub 0. Then theorem 1 is telling us that the limit ng function times a constant ay equal sa constant na yon times the limit of the function. Statement number 2, the limit of a sum is the sum of the limits. Statement 3, the limit of a product is the product of the limits. And lastly, the limit of a quotient is the quotient of the limits. Which is very kamukha, napaka-konyotic, no? na medyo kamukha no nakita na natin para sa sequences. Alright? So sa Math 36, malamang pinurove nyo rin to, pero again, epsilon delta yung dinaanan nyo. But now I can take advantage of Theorem 3.1. Tapos i-convert ko yung statement, yung assumptions about the limit of the functions f and g. Ibababa ko siya papunta sa limit ng sequences. Then I will appeal to Theorem 2.3, which is the algebraic limit theorems for sequences, para maka-deduce ng isang result. Tapos yung result na yon, i-convert ko into a statement involving functional limits using the converse of theorem or using the other direction of Theorem 3.1. So parang ganun yung magiging template pag gusto nyong i-prove yung mga statements dito sa Corollary 3.2. Actually, it's not just for Corollary 3.2, pero para rin sa iba pang mga statements involving limits. May ganung ruta. Theorem 3.1, then use a theorem from sequences, and then translate that using Theorem 3.1 para dun sa final thing that you want to prove. Okay? Sige, sampulan ko kayo. Pili tayo ng isa rito. Almost same difficulty naman yata itong mga to. Mas mabilis lang isulat yung part 1. So, ang ipoprove ko na lang ay part 1. Tapos, try on your own to write a formal proof para dun sa remaining statements. All right? So, here, let's try to have a proof for statement 1. In statement 1, ang assumption nun ay, so we assume that the limit of f of x as x approaches x sub 0 ay equal kay L. So ipakita na yung limit nung f of x times a constant ay equal sa k times L. Alright? So ayoko mag-epsilon delta, gagamitin ko yung theorem 3.1. So by theorem 3.1, for any sequence x sub n properly contained in this set that converges to x sub 0, we have f of xn converges to L. All right? So ito yung sinabi ng theorem 3.1. The existence of such a sequence is guaranteed by x sub 0 being a limit point. Ito yung dahilan kung bakit gusto natin si x sub 0 na kukunan natin kung saan natin kukunan ng limit si function ay laging limit point. Para magkaroon ako lagi ng isang sequence ng mga elements ng domain na nagko-converge kay x sub 0. Because if that is not part of our assumptions, then hindi tayo sure na lagi nating magagamit si 3.1. Nagagamit natin lagi si Theorem 3.1 kasi sure tayo na merong laging sequence na dumaraan dun sa mga elements ng domain na pwede nating na pwede nating i-observe yung behavior ng elements ng sequence na yon and the function values of the terms of that sequence. Okay? So yan. Tapos, meron ako ditong statement about a convergent sequence. Now, I'm gonna go back into to Theorem 2.3. Sabi ron, kapag ka meron kang convergent sequence, alright, kapag ka minultiply mo yung mga terms ng sequence by any constant, alright, convergent pa rin yun. At magko-converge siya doon sa limit, original limit, times the same constant that we use to multiply each of the terms in the sequence of function values. Okay, so this is by the algebraic limit theorem for sequences. And I think sabi rito siya ay theorem 2.3 galing sa module 2. Okay, so theorem 3.1, ginamit ko siya to convert. Tapos nakakuha ko ng result mula sa, or gumamit ako ng isang result mula sa sequences. Third part na ng ating recipe, i-convert na lang itong limit atong sequence statement na to papunta sa isang functional statement. Right? And that is via the converse of theorem 3.1. Okay? Kaya sabi nito, sa kahit anong sequence ng mga xn's, laging totoo ito. So that means by theorem 3.1, it follows that the limit of k times f of x. Ngayon, pinalaki ko na yung domain ni f. Kinonsider ko na yung mga x's na nakay a pero wala dun sa sequence x sub n. And I take the limit as x approaches x sub 0. Equal yan dito sa limit nung sequence. Equal pa rin siya kay kl. Which is essentially what was claimed here in this statement over here. And that ends the proof. Nung statement number 1. Okay? And then a similar proof can be written for the rest of the statements. And I'll just leave them as an exercise for you. Okay? So I hope nakikita nyo kung ano yung utility ng Theorem 3.1. Paano nyo napadali yung pag-analyze natin ng mga statements involving limits of functions. Alright? Now, sige, tingnan pa natin. Isa pang corollary. But this corollary is another useful tool. Okay? Ito yung sinasabi ko kanina na magkakaroon tayo ng isang tool para ma-check or para ma-prove na isang number ay hindi ang limit ng isang function. Okay? Let's call this the divergence criterion for functional limits. So dahil sabi ng Theorem 3.1, pag kumuha ka ng kahit anong dalawang sequences dun sa domain na nagko-converge kay x sub 0, alright? laging yung sequence of function values nila ay magko-converge kay L. Now, if you will get the negation of that, negation ba ang tawag? Inverse nga ba? Converse, contrapositive, inverse, converse, basta. Pag kinuha natin yung parang negative nung idea na yon, alright? So, pagka kumuha ka daw ng kahit anong dalawang sequences na nagko-converge kay x sub 0, yung limit ng sequence ng mga function values lagi daw magko-converge to L. Pero ano ang mangyayari kapag kumuha ko ng dalawang sequence, tapos parehas sila nagko-converge kay x sub 0, pero magkaiba yung limit ng sequence ng mga function values nila? To avoid contradicting theorem 3.1, we are forced to conclude that the limit of f of x does not exist. Alright? So pag nakakuha ka ng dalawang sequence na nagko-converge kay x sub 0, pero yung sequence of function values ay nagko-converge sa dalawang magkaibang bagay, ibig sabihin yung limit ng function ay hindi nag-exist. Alright? I think this is a much more generic statement than what we had when we talk about one-sided limits sa Math 36. Kasi essentially, ang sinabi mo sa Math 36, pagka halimbawa kinuha mo lang yung mga function values mula sa kanan, nakakuha ka ng limit na L1, kinuha mo yung limit ng mga function values mula sa kaliwa, tapos nakakuha ka ng isa pang number, sinasabi natin the limit doesn't exist. Alright? Mas generic to kasi hindi lang galing sa isang direksyon. Kahit saan nanggagaling yung mga terms ng sequence, kahit sa kaliwa, kahit sa kanan. Pero pag nakakita ka ng dalawang sequences na magkaiba yung limit ng function values, then hindi na nag-exist yung limit ni f. Okay? So that's basically the idea behind the proof, all right? But we'll not dwell too much on the proof. Basically, na-force lang tayo to conclude this para hindi ma-contradict yung theorem 3.1. So what you can do to write the proof, possibly one approach, is to do it by contradiction. Suppose that the limit do exist and it's equal to some number. Tapos kung ito yung assumptions mo, siguradong ito will be contradictory or will be contradicted by a consequence of theorem 3.1. Okay? So it would be also a nice exercise. So kindly try to write that proof. Pero gusto kong mag-focus by showing how this theorem is used. Okay? Ito yung example 3.4. Sabi sa example 3.4, ipakita raw natin na ang limit ng sine 1 over x as x approaches 0 ay hindi nag-exist. Okay? Sa Math 36, kailangan mo yung epsilon delta, ipakita mo na imposible siya maging equal sa kahit anong real number, which I think is quite difficult. Okay? Now, thanks to corollary 3.3, meron tayong mas madaling paraan para masagutan yan. Okay? So, ang gagawin natin, maghahanap tayo. Actually, may question mark pala to. Madali nga ba yung paraan? Kasi theoretically, parang maganda. Maganda yung corollary 3.3, right? Pero ang problema rito, we need to build two sequences. Ano yung kailangan sa dalawang sequences na yan? Okay, medyo madali yung unang requirement. Dapat yung dalawang sequences magko-converge kay x sub 0. Pero the kicker is, dapat yung sequence ng function values mula dun sa dalawang sequence na yon, magkaiba yung ina-approach na value. So we have to create two sequences and pray na yung consequent sequence ng mga function values ay magkaiba ng limits. That's actually the challenge for the use of corollary 3.3. Okay, tingnan natin yung 3.4. Alright. Medyo madali yung una kasi kailangan lang natin mag-construct ng isang sequence o ng dalawang sequences na nagko-converge kay 0 mula dun sa domain. Alright? So sabi ni handout, okay, tingnan natin yung sequence ng mga x, tawagin natin 1 over 2 and pi. This will obviously approach 0 because when n becomes large, the denominator becomes very, very large. The constant 1 divided by a very, very large number will be a very, very small number that approaches 0. So yung limit ng sequence xn ay equal kay 0. Tapos sige, mag-invento pa ako ng isang sequence. Alright, Sa lahat ng mga sequence na pwede kong maisip, ito yung pipiliin ko. 1 over 2n pi plus pi over 2. Okay? Makikita natin mamaya kung bakit convenient choice ito. But let's first check. Magko-converge ba ito kay 0? Well, when n becomes very, very large, 2n pi becomes very, very large. Tapos dadagdagan ko pa ng katiting, pi over 2. So that means this is a very huge number again. Constant divided by a very huge number, that will tend to 0. So indeed, the limit of the yns is also equal to 0. Tapos ito na yung naka-fingers crossed na tayo. Alright? Sana, yung f of xn magko-converge sa isang number na iba dun sa limit ng f of yn. Yun yung magiging pinakamalaking balakid para magamit yung corollary 3.3. But let's see. F of xn. F of xn ay sine ng 1 over xn. Pero si xn ay 1 over 2n pi. Okay? Pag sinimplify ko yan, sine lang lamang ng 2n pi. So, ibig sabihin, sa unit circle, nandito lang tayo palagi. Multiple kasi tayo ni 2 pi. Alright? Tapos ang sine, sa lahat ng multiples ni 2 pi, ay laging equal kay 0. So, ibig sabihin, yung sequence of function values na manggagaling dun sa sequence xn is just a constant sequence. A sequence consisting only of zeros. And obviously, that will tend to 0. So, yung sequence f of xn natin ay magko-converge papunta kay 0. So now, we are hoping na yung f of yn ay hindi magko-converge kay 0. And dito nyo makikita kung bakit seemingly out of the blue, I added a pi over 2 dun sa denominator. Okay? Tingnan natin. F of yn. Ito ay sine ng 1 over yn. Tapos, ito ay sine ng ang yn ay 1 over 2n pi plus pi over 2. Okay? So, this is basically sine lamang ng 2n pi plus pi over 2. So that means in the unit circle, sorry na, hindi ako nakapag-evaluate ng sine at cosine hanggang ngayon nang walang unit circle na katabi. So lagi ako mag-drawing ng unit circle sa gilid. So 2n pi ay laging nandito lamang sa origin ng or dito sa 0 degree angular line. Tapos magdadagdag ako ng pi over 2, so lagi ako mapupunta dito. Tapos ang sine value dito ay laging positive 1. So now, masaya tayo. Kasi yung sequence ng mga function values ng mga yns ay consisting lamang ng mga 1s. And so we can say that that sequence will converge to 1, which is different from 0, which is the limit of the sequence of the function values of the xn. So what we have found here are two sequences, both converging to x of 0, which is 0, but the sequence of function values have different limits. So therefore, we can indeed conclude that this limit does not exist. All right? Questions? Okay lang ba na ganitong klase ng problem yung ibigay ko sa homework? Anyway, meron naman kayong ilang araw para mag-imbento ng sequences. Alright? Sige, isa pang example. Nakalimutan ko pa rin palang i-edit yung statement number 2 rito. Okay? Sinabi lang si Dirichlet function, pero kahit hanapin nyo kung saan man dyan sa module, hindi nyo makikita nasan yung 3.1. Sige, ito na lang ibigay kong example para makilala nyo rin yung Dirichlet function. Okay? Ano nga ba yung Dirichlet function? Well, the Dirichlet function is the characteristic function or the indicator function of the set of rational numbers. So, ibig sabihin, kung si f yung tatawagin nating Dirichlet function, ang f of x is just either equal to 1 or 0. Okay? Equal siya kay 1 kapag yung input ay rational, equal siya kay 0 kapag ang input ay irrational. That's the Dirichlet function. Okay? And then say we want to show that, say we want to show that the limit of f of x as x approaches 0 does not exist. Bawa, yun yung problem. Paano natin papakita na yung limit ng Dirichlet function as x approaches 0 does not exist? All right. Now, we can use corollary 3.3. So all we need to do is to devise two sequences converging to 0, but will have different limits, or whose sequence of function values will have different limits. Okay. Sige, ako na yung magpapauna. Ako yung mag-isip ng unang sequence. I'll consider the sequence 1 over n. The sequence 1 over n clearly converges to 0. And then kukunin ko yung f of 1 over n. Yung f of 1 over n, okay, remember n's are natural numbers, okay? Kasi sequence nga yung 1 over n, so yung mga n natural numbers. Kukunin ko yung function value ng mga 1 over n. Pero si n ay natural number, so yung 1 over n will be rational. Function value ng rational under Dirichlet ay equal kay 1. So yung sequence ng mga function values ay magko-converge kay 1. So ang challenge sa inyo ngayon, mag-isip ng isang sequence na nagko-converge kay 0, pero yung sequence of function values ay hindi magko-converge kay 1. Any volunteer? Can you give me ano yung sequence na pwede kong gamitin? Ito yung sinasabi ko na challenge. Alright, practice nyo na to para sa homework. Okay, anyone? Yung question ay, ano yung sequence na pwede kong gamitin para ma-conclude na yung limit doesn't exist? So I mean, think of a sequence from the domain, which is R, that converges to 0, pero yung sequence ng function values ay hindi magko-converge kay 1. Alright? So ano tong sequence na to na dapat mag-converge kay 0, pero ayoko na yung function value niya ay magko-converge kay 1. Kasi kung nag-converge kay 1 yung sequence ng mga function values, then wala tayong conclusion pang makukuha. Alright? Kasi baka hindi lang natin nahanap yung appropriate sequence. Alright? Para magamit kasi si Theorem 3.1, dapat lahat ng sequence ay magko-converge, lahat ng sequence of function values ay magko-converge dun sa same number. Pero gusto ko ipakita, si f ay walang limit as x approaches 0. Ibig sabihin, posible tayong makahanap or dapat makahanap tayo ng isang sequence na nagko-converge kay 0 na yung sequence of function values will not converge to 1 para magamit ko yung corollary 3.1. So the big question is, ano yung sequence? Or magbigay kayo ng isang sequence that will do the job. Okay. That I think you mean ano yung CBRT? I think SQRT ba yan? Jonathan. Cube root. All right. Naging mas fancy pa si Jonathan. Okay, that's fine. 1 over cube root. So dahil dyan, exempted ka na sa homework, Jonathan. So paki-comment na lang dun sa chat na exempted ka na sa homework, sa susunod na homework. All right. So kasi ganito rin yung papagawa ko sa isa inyo. So yeah, yung 1 over cube root of n will be a nice sequence because 1 over cube root of n will definitely converge to 0. But if we investigate the Dirichlet function value of 1 over cube root of n, all right? Ano yung mangyayari dyan? So ilista natin yung elements ng sequence. When n is equal to 1, this guy will be 1, f of 1 is 1. But if n is equal to 2, this will be 1 over cube root of 2. Irrational yon, so 0. When n is equal to 3, magkakaroon ulit tayo ng 0. N equals 4, 0 uli yan. 5, 6, 7, 8. Ay, na, tama. Kay 8 pala ako titigil. Kasi kay 8, ang function value na uli niya ay 1. So sa lahat ng mga perfect cubes, 1, Sino susunod? 8, 27. Sino pa susunod? 4 cube. 64 na ba susunod? Basta dun lang siya sa mga perfect cube nagiging 1. Tapos, sa dulo ng listahan, lagi kang may makikitang rational at irrational na 1 over cube root of n. So, ibig sabihin, this will be divergent. So, this diverges. Okay? Kasi hindi natin alam kung ano yung mangyayari sa dulo. Kasi sa dulo ng listahan, lagi pa yung merong mga zeros, tas may susulpot na 1, tas puro zeros na naman, pero out of the blue, may susulpot na naman ng 1, tas puro zeros na uli, may susulpot na 1. That is a never-ending process. So there is no uniform behavior in the long run. Okay. So dahil nakakita si Jonathan ng isa pang sequence na nagko-converge kay 0, pero yung function values ay hindi magko-converge kay 1, then we can conclude that the Dirichlet function doesn't have a limit as x approaches 0. Okay? Isa pang posibleng sagot ay 1 over square root of n, pwedeng 1 over 4th root of n, at kung ano pang roots ang maisip nyo. Alright? So sige, isa pa. Meron pa ba kayong naisip? Aside from yung mga roots. So bawal na yung may mga roots ha. Sino pa may naiisip na posibleng sequence na magamit para ma-conclude na yung limit doesn't exist? Sige nga, ang clue, basta dapat yung sequence nyo nagko-converge kay 0 pero hindi dapat puro rationals. Kasi pag puro rational, yung kinolect nyo dun sa sequence, magko-converge kay 0 yung sequence nyo. So if you can create a nice sequence that will not solely contain rational numbers, then there's a big chance that sequence will suffice. Sige, may habol pa ba na exemption sa next homework? Basta bawal na yung mga roots yung kamukha ng example ni Jonathan. Sige, sayang naman. Titigil na ako rito. So, sige, isip pa kasi sayang naman. Kung may maiisip kayo ngayon, edi free na kayo sa homework. Sige, we can stay until 3:55 para mag-isip. O diba, saya 5 minutes lang tapos na kayo sa homework. Bawal din yung negative 1 to the power n over square root ni n. Nag-alternate lang yung sign. Pero kamukha pa rin yun nung example ni Jonathan. Dapat pala mag-play ako ng Jeopardy song para habang nag-iisip kayo merong Okay, I think Charles' suggestion is good. So sabi ni Charles ay ang sequence niya ay 1 over pi to the power n. So basically nagkaroon ka lang ng exponent dun sa denominator. Okay? Let's see why this will work. Of course, this will approach 0 because when n becomes very large, and pi to the n will be humongous, all right? 1 divided by a humongous number that will really approach 0. So that's good. Check na yung number 1. Yung pangalawang requirement, kunin natin yung function value ng 1 over pi to the n under the Dirichlet function. Kahit ano pa yung n, yung pi to the n ay irrational pa rin. 1 divided by an irrational number will still be irrational. So this guy will always be irrational. So it will be a sequence of zeros. So dahil dyan, Charles, exempted ka na rin. Congrats sa susunod na homework. Alright? Kasi yeah, this is also sufficient to tell us that the limit doesn't exist. Sige, isa pa. So, bawal lang yung mga roots, tapos bawal lang din yung kamukha nito, yung may power ni pi sa denominator o power ni e. Bawal na rin yung power ni nung kung anumang irrational. So, may naisip pa ba? May gusto pa bang humabol? Oh, may 2 minutes pa. Actually, ano pa ba? May isa pa ako naisip na hindi ganun kakomplikado. Sirit na ba? Sige, type mo Jonathan. Ayun na yatang sumagot ni Ana sa kanina ni Risa. Oh, yun, meron pala si Nerissa. Si Nerissa sabi niya ay 1 over log of n. Si ano na lang, isa na lang yung walang entry. Ana, baka gusto mong humabol. Yeah, I think Nerissa's answer is also right. 1 over log or 1 over any logarithm ng n. Kasi pag si n ay lumalaki, yung log ay lumalaki rin, 1 over malaki, mag-approach ng 0. Then this is almost always irrational, except when n is what? When n is a power of the logarithmic base. Okay. So kapag ka si n ay power ni 10, saka lang siya magiging rational. Kung yung ln ni Jonathan yung gagamitin natin, then yun yung sure tayo laging irrational. Yung 1 over log, 1 over ln n. Tama ba? Yes, kasi for any natural number, yung ln n ay laging irrational. Okay? So, meron pa bang habol? Going once, going twice, going thrice. Okay, close na. Yung isa ko pang naisip, ako naman yung e-entry. Pi over n, yung fraction of pi over n, right? So when n is a natural number, pi over n will always be irrational. Or pi over any rational number will be irrational. So yung pi over n, o kaya pi over 5 over 17, whatever, lagi yung magiging irrational. Tapos magko-converge to kay 0 kasi habang lumalaki si n, hindi naman nagbabago yung numerator, so mag-approach siya ng 0. Tapos irrational siya lagi, so ang sequence ng function values will consist only of zeros, which will converge to 0, different to 1. Okay? So I think we can stop here. So any questions, parting words? Okay, so if there are none, so we'll see each other again on Tuesday. Pero watch out for the homework that will be live on Canvas tomorrow at the latest. And then that deadline, its deadline would be on Tuesday, right before midnight. Okay. So until then, stay safe, guys, and then enjoy the weekend. Bye-bye. So pa-comment na lang na kasi baka makalimutan ko. Jonathan, Nerissa, and Charles, palagay naman na exempted kayo dun sa homework. Baka makalimutan ko kasi. Salamat.